All right, this section is about compound probability formulas. All right, and our first formula that we have here is for the probability of event B given event A. And the formula says to find this probability when this situation is occurring, we're going to take the probability of A and B given the or divided by the probability of A. So take a look at how this works in the formula. All right, and then we're going to apply this formula in a couple of situations. So, if I take a look here for the pharmaceutical testing, it says in a study designed to test the effectiveness of a new drug, half the volunteers received the drugs. The other half of the volunteers received a placebo, a tablet or pill containing no medication. The probability of a volunteer receiving the drug and getting well was 45%. What is the probability of someone getting well given that he received the drug? So if I'm looking at what this says, I noticed the part that I highlighted means the probability of getting well. Why don't we just say the probability of well given the probability of getting the drug. All right. So if this is the case, then I know to calculate this. I'm going to take the probability by using the formula of getting well and the drug, or you could say drug and well. And we're going to divide that by the probability of getting the drug. All right. So now I'm going to take the data that's in the description here and put it in here. All right. So the probability of well and drug, or drug and well, here it is. The probability of drug and well was 45%. So I'm going to write that as a decimal. The probability of the drug, back up at the top, it says half got the drug and half didn't. So that tells me the probability is 0.5. If I divide these two together, I get 0.9, which we could write a couple of different ways. We could write as 90%, or we could write 9 over 10. So this is how I'm going to do a conditional probability. All right, let's try another one here. It says the probability of a volunteer receiving the placebo and having his or her health improve was 20%. What is the conditional probability? So again, here's the question. The conditional probability of a volunteer's health improving given that they received the placebo. So it's the probability of getting better, or what we called it before, getting well, given that this time they got the placebo. All right? So once again, the way that I do this is the probability of well and placebo, or placebo and well, divided by probability of the placebo. Notice how the given is the denominator. Okay? The given part of it is the denominator. So let's see. In this case, well and placebo. All right? So having his or her health improve and getting the placebo was 20%. So I know this is going to be 0.20. And the probability of the placebo, well, if you remember, in the problem it said half got the placebo and half didn't. So that means the probability of the placebo was half, or 0.5. If I divide this out, I get 0.4, which is 40%. Or if they wanted me to write it as a fraction, it would be 2 over 5. All right? So let's take a look here. I have another statement in here that says conditional probabilities are usually not reversible. And what that means here is just because you can find the probability of A given B, that doesn't necessarily mean the probability of B given A is going to be the same. It could be. It doesn't necessarily mean that it is. That's why reading these is so important. All right? So our next problem says, in a survey of pet owners, 45% own a dog, 27% own a cat, and 12% own both a dog and a cat. I noticed right there, and, so I'm thinking, all right, this is going to be conditional, which they tell me, but I see the and in there, so that's going to be my numerator in these conditional cases. The first question says, what's the conditional probability that a dog owner owns a cat? So they're giving us that the owner is a dog. If I were going to write this, I would say the probability of a cat given that I'm a dog owner. So to figure this out, we're going to take the probability of cat and dog, or dog and cat means the same thing, which would be 12%, divided by the probability of, because of how it was asked, the probability of a dog, which would be 0.45%. If I simplify this, I can simplify it to, let's see, this would be 4 over 15. Or if I wanted to change it to a percent, I would say this would be 26.7%. So 26.7% of the people that own a dog also own a cat. All right? Let's look at the reverse of this. What if it's the probability of, as they ask here, a cat owner also owns a dog? So the probability of owning a dog, given that I'm a cat owner first. I'm primarily a cat owner. So this would be probability of dog and cat, which was 12%, divided by the probability that I'm a cat owner. That was 27%. As a simplified fraction here, this would be 4 over 9. And again, if I wanted it as a percentage, I would say this is 44.4%. So one thing that I notice here is if I reverse the type of owner that I am primarily, the given that part, it changes the percentages. All right, so that's what we got to be paying attention to very closely. Now they extend it a little bit. So in the same survey, it's still the same data points up here. 45% own a dog, 27% own a cat, 12 own both a dog and a cat. We have this one that says 5% of the pet owners own a dog, a cat, and at least one other type of pet. All right, so they're just taking this scenario and extending it. First question, what is the conditional probability that a pet owner owns a cat and some other type of pet, given that they own a dog? So they're giving us the conditional statement here. The probability of a cat and other, given that they own a dog. All right? So to simplify or to figure this out, I know that this is saying the probability of a cat, other, and a dog. Well, that's that 5%. Divided by the probability of a dog, which would be 0.45, if my memory is right. Let me look up there. Yeah, 45% on a dog. So if I simplify this fraction right here, it simplifies to 1/9. And again, if I wanted a percentage, since the question is given in percentages, I might say that this is 11.1%. Part B here. What's the conditional probability that a pet owner owns a dog and some other type of pet, given that they own a cat? All right, so the probability of dog and other, given that they were first a cat owner, so they view themselves as primarily a cat. All right, dog, other, and cat, that would be 5%, 0.05. And the probability that I am a cat owner would be 27%, or 0.27. This would simplify to 5 over 27, or as a decimal, I get 18.5%. All right, the third type of scenario that we have to deal with here is, or it can kind of be broken down a little bit using this idea. So here's what we started off with today's lesson. We said the probability of B given A is the probability of A and B divided by the probability of A, divided by the probability of what was given. If I solve this as an algebraic equation, I get that the probability of A and B is the probability of A times the probability of B given A. All right? So it's just a unique way to look at and probability. Most of the time, our ands are going to be a multiplication, like we talked about before. But this is unique because we have a given situation. A lot of times a conditional situation. A lot of times this conditional kind of plays its part through the use of something called a tree diagram. All right. So for example, let's take a look at this question. They're going to give us a bunch of data points. 70% of the freshmen, first of all, we're at a college and they're looking at the graduation rates. 70% of the freshmen that are in this college came from public schools. 60% of those freshmen who attended public schools graduated within 5 years. 80% of the other freshmen graduated within 5 years. And then the question comes up to say, what percent of freshmen graduated in 5 years? Well, there's a slew of data here. You either went to a private or a public, okay, and then you went and you either graduated or you did not graduate. So the way to do this is to organize your data. The first thing I'm going to do is I'm going to organize to where the freshmen came from. They either came from a public or from the other. Now, they tell us in our data that 70% of their students came from public. That means that 30% of their students came from somewhere else, typically a private. All right? So from the public, we now can identify those public students, 60% of them graduated in 5 years. So we're going to take from this public and look at, did they graduate or not in 5 years? All right. So they tell us statistically that 60% or 0.60 graduated in 5 years, which means 40% did not. If you look at the other, grad versus non-grad, they tell us that the probability or the percentage of those that graduated in 5 years that were in the other category, 80% of them graduated. So this would be 0.80, and this would be the other 20%. All right? So to determine the probability of those that graduated, probability of graduated, what we would do is take the probability of those that came from public and graduated and add to that the probability of other and grad. All right? So in order to calculate this, I know that the probability of public and grad, public and they graduate, can be found because it's an and statement. I can take 60% and multiply that with 70%. Probability that they graduated, 60%. Probability that they came from public, 70%. And really remember that graduated part right there is really graduated given that they came from a public school. All right? I'm going to add to that the other and grad, so that's 80%. So again, that 80% is really graduated given that they came from somewhere other than a public. And multiply that with the probability that they came from the other, which would be 30%. All right? Hopefully that makes sense. I know this is a little bit more challenging, but hopefully my explanation makes sense. If I multiply these together now, I get 42% and 24%, which tells me the probability of graduating would be, 0.66 or 66%. Your probability of graduating, whether you came from public or other, is 66%. Believe it or not, this is a pretty accurate statistic. All right, about 66%, or about 2/3 of those people that enter college graduate within 5 years. What does that mean to you? 34% don't. All right, so maybe something to think about, how your effort is and different things. Anyway, let's get off the pedestal here and let's finish this out. So this one now says the soccer teams win 65% of its games on muddy fields and 30% of its games on dry fields. The probability of the field being muddy for the next game is 70%. What's the probability that the team will win their next game? All right. So if I'm trying to calculate this probability, immediately I'm thinking of the probability of a win. Now, the probability of a win comes from the probability of a win and muddy plus the probability of a win and dry. All right. So I can make a diagram just like I did up here, or I can use the information and see if I can piece this all together. Let's try it that way for this one. So the probability of a win on a muddy field. Here's what I know. I know that they win 65% of their games on muddy fields. All right. So I know that they're going to win 65% of their games. And I know the probability of it being muddy is 70%. All right. The second scenario, probability that they're going to win and it'll be dry. Now, they don't tell me straight out what the probability of it being dry for their next game is, but I can deduce that. I know the probability of a win on a dry field, they win 30% of their games. And the probability in this scenario of the next game being dry is also 30%. I deduce that because the probability of it being muddy is 70%. All right. So if I do the arithmetic here, I get 0.65 times 0.70 would give me 0.455. And 0.30 times 0.0 would give me 0.09. Sorry. 0.09. If I add these together, I get 0.545, which would be 54.5%. So there's a good chance that they're going to win, all right, given no matter what the conditions are. There's a more than 0.5% chance that they're going to win. Hope this helps. Make sure you guys have Math Excel done, and thank you very much for behaving yourselves while I'm out. Thanks.